Hi guys, so today we'll be solving this problem called max chunks to make sorted. We've been given an integer array of length n that has permutation of integers between 0 to n minus 1. We need to split this array into some number of chunks such that each chunk is individually sorted. And once we concatenate the entire chunks, we get a sorted array. And we need to return the largest number of chunks we can make from the array. So let's try to understand with an example. So first one, 0, 2, 3, 4, right? So in this one, what we can do is we can split this array into 1, 0, which is one chunk, 2, 3, and 4. So here in this chunk, if it is sorted individually, so 0, 1, 2, 3, and 4, we get like four chunks, which basically, if merged together, form a sorted array. So that's the idea. Uh, the approach that we can follow, one is a trick approach that we can actually, because we know that um, the indexes needs to be like will be equal to the so indexes are actually in sorted form, right? So the values also need to be like that, which means that the sum, prefix sum, should be equal. And by doing that, we'll know the number of chunks that it can form. So for example, so let's do a sum, prefix sum of the values and also the indexes. So this is for values and this is for indexes, right? So we are here. So 1, so prefix sum is 1 and index is 0. So prefix sum is 0. Then we move to 0 and prefix sum is still 1. And here we add 1. So prefix sum is 1 now. So here if you see, once the value equal to index, right? The prefix sum of value equal to prefix sum of index, we know that we can actually divide this into one chunk, right? So that means that we can divide, like we have one number of chunk. Then moving to the next, we have 2. So 1 plus 2, 1 plus 2, which is 3 and equal. So which means that we can divide into another chunk again. So this becomes 2. And similarly, we go ahead, we have 3 and 3 plus 3, 6. So we have again equal, right? So we can divide it into third chunk. And again, same, we can divide it into fourth chunk. So this is one solution. There is one more solution for using the stack approach. So in this, what we can do is 1, 0, 2, 3, 4, right? So the idea is to maintain a monotonic stack, right? Which stores the largest number at the top always. So it would be like something like um, once we iterate through the array, let's iterate through the array. So we have 1. So I'll put 1 into the monotonic stack, and moving to the next, I have 0. So here I have two options. So the array of I can be either be greater than the top of the stack, or array of I can be less than the top of the stack. So which means that when can we merge into a chunk? So we can merge into a chunk when array of I is smaller than the top, right? So which means that whenever there is like a smaller number in the array compared to the one which is already present in the stack. Stack basically denotes the chunk. So if it's already present in the chunk, we know that we can sort it out and merge it together. So here 0 is less than the top, right? So which means that we'll always will actually we will not store it inside the monotonic stack, because monotonic stack will be storing the max element of a chunk. So yeah, here it is 0. So 0 would not be stored because yeah, max element is 1 and 1 is still greater than array of I. So what we can do is we can we'll be doing this in this example. It's not that we need to actually find a way to remove elements from the stack, but we'll be doing it later on. So here in this case, we don't need to, but yeah, we move ahead. We move ahead to 2. So 2 is actually in this case. So 2 is greater than the top, right? So which means that it can actually form an individual chunk in itself. So 2 will be added there. Then we have 3, right? 3 is also greater than the top of the stack. So it can actually form an individual. Yeah. And then 4. 4 is also greater than the top of the stack. So that can also form an individual. So in the case where uh, we need to we need to actually see that uh, this how, like, if there is like a single chunk being formed. So for example, let's take the first example, 4 3 2 1 0, right? 0 1 2 3 4. So in this case, we will, so let's say 4, right? So 4, we'll push that 4. Now we have 3. So 3 is smaller than the top of the stack, right? So 3 is smaller than the top of the stack, which means that what is the max element in the stack right now? It's 4, right? So 3 is, so yeah, 3, we don't need to push any 3 because monotonic stack is denoting the max element of a chunk. So 4 is the max element, so we don't need to do anything. We just go ahead. 2, right? So 2 is also smaller than the top of the stack, right? So in this case as well, we'll get the top of the stack, which is 4, and yeah, 4 is still greater than the 2, so don't do anything. 1, same thing, because 1 is smaller than the top of the stack. 0 is greater than the top of the stack. So yeah, in this case, the size of the stack is 1, and that's the number of chunks that we can form to make it sorted, right? So yeah, that would be the idea. Let's get to the coding part. Right. So let's get to the coding part. So first of all, I'll maintain a monotonic stack, and I'll iterate through the array. So initially we have two conditions, right? So first is if the stack is empty or array of I is greater than stack dot top, then what do? We just push the array of I, right? The other condition was that if it's smaller, right? So while so what in this case we'll be checking if the array of I is smaller than the top of the stack, and if not, right, so we'll remove all the elements which are not. So we are only storing the maximum number of the chunk, maximum element of a chunk. So it will be like something like stack dot empty, or um or stack of stack dot top of I not empty, and then array of I is smaller than stack dot top, then stack dot top, everything which is irrelevant, we'll only store the max element of the stack. So yeah, we remove everything else which is irrelevant because we are only storing the maximum number of a chunk, and we'll push the max element so that we maintain the maximum number of the chunk, right? And in the end, we'll just return the stack dot size. That would be the idea. Cool. So let's run the code to see if everything is working fine. Yeah, that works. Cool. So I hope you liked the video. Thank you.